Hello viewers, welcome back to Easy Mathematics. We thank God for another wonderful day and another opportunity to bring to you the lesson we started last week in Basic 8. We want to continue from where we stopped in Basic 8. Last week we looked at finding or knowing what a perfect number is and what a perfect square is. So we concluded by saying that a perfect number is a number whose sum of its factors are the same as the number except or excluding the number itself. That number is a perfect number. And we also said that a perfect square is a number which is the square of an integer. So the product of an integer by itself gives us a perfect square. Good. But today we want to look at how to find a perfect square. Now we know that finding a perfect square or finding the value of a perfect square is simply or introduce us to what we call the square root of a perfect square. Now when we say square root of a perfect square, it simply means that we are going to look for that integer when it is being multiplied by itself gives us the perfect number. So for example, if you take 2 times 2 for example, this 2 times 2 happens to give us 4. See, gives us 4. So if I've been asked to find the square root of 4, then it is asking what integer will it multiply itself to give me the 4? And that gives me the result 2. So the square root of 2 simply means that what integer or which integer multiplied by itself gives us this perfect square. Good. So we are looking at finding the square root of a perfect square number. Finding the square root. And the square root is given as this. This being the what? The square root. So if this being the square root, then the square root of a square, of a perfect square, is the integer that gives us the perfect square when it has been multiplied by what? By itself. So if I take the square root of 100, square root of 100, first of all, I should know or be able to determine that the 100 is a perfect square. It is a perfect square because it is the product of an integer by itself, or it is the square of an integer. So what number, once I've been given something like this, it means, or ask yourself, what number times itself will give me the value in the square root? What number times itself? So we all know that multiplying 10 by itself will give us the number in the square root. So the square root of 100 happens to be what? 10. Now it is 10 because if I multiply 10 by itself, it will give me the square root of what? Of 100. Now that's going to give me what? 100. Good. Now, in calculating this, the reason why the answer is 100 is because now we know what we call indices, or the power of a number. So because 10 times 10 will give me 100, this 10 times 10 is the same as 10 raised to the power 2. Okay, this 10 times 10, which is the same as 100, is giving me 10 times 10 raised to the power what? 2. So if I'm having these two to be 100 in the square root, then we say that it is going to what? Cancel out. So let's look at the example. The example says, find the square root of the following numbers. Now we have two ways of finding the square root of a square, of a perfect square. We'll look at both quickly, then we look at the next one. So now, if I'm to find the square root of 81, first of all, finding the square root of 81 is asking me to find the integer that can be multiplied by itself to get 81. So if I use that integer to multiply itself, then that integer is going to give me that integer square. So what number times itself will give us 81? It's 9. So in the square root, we can write that 9 times 9 is the same as 81. But since 9 is multiplying itself 2 times, that gives me 9 to the power 2, or 9 square in the square root. So if 9 square has been given as a square root, or it is in a square root, then we are going to say the square root can therefore cancel the square, and that gives me a final answer of what? Of 9. So this is the easiest, or this is the simplest way we can just find the square root of what? Of a perfect number. Know that the perfect number, the integer can be multiplied by itself. So once the integer can be multiplied by itself, then it's a perfect number. Case closed on that. So here, which number? I have to know the number that if I'm to multiply the number by itself, it will give me the number in the square root. Because we said that this sign is what is referred to as what? As square root. So if 81 is in the square root, then what number times itself will give me 81? 9 times 9. Okay? 9 times 9 will give me 81. Now, per indices which we did, indices is given as 9 squared. Why is it 9 squared? When we're looking at prime factorization in basic 7, we were told that when a number multiplies itself 2 times, that is the same as the number raised to the power 2. If the number is multiplying itself 4 times, then it is the number raised to the power 4. So this 9 times 9 is the same as the 9 squared. So the square has the power to cancel the square root, and we are therefore left with what? With 9. So this is the other way that we can also find the perfect, we can also find the square root of a perfect number. But now, there is another way of finding the square root of a perfect number. Now with that number, or with that method, we are going to make good use of all the odd numbers starting from 1. All the odd numbers in order. And what are the odd numbers? The odd numbers are 1, 3, 5, 7, 9, 11, and so on and so forth. So with the second method, we are going to use the odd numbers in a method called repeated subtraction. In a method called repeated subtraction. What are odd numbers? Odd numbers are numbers that cannot be divisible by what? By 2. So if that number cannot be divisible by 2 or cannot be divided by 2, then that number is said to be what? To be an odd number. So here, another method for which we can be asked to find the square root of a number is by using the repeated subtraction method. Now with the repeated subtraction method, what are we going to subtract? We are going to subtract each of the odd numbers from our result depending on the number we have here. So if I want to use the repeated subtraction method, then the number that I have been given, I am going to take that number, which is 81. Now this 81, subtract the first odd number from 81. So we have here as 81 minus the first odd number. That is giving us what? 80. Now with this result, which is 80, take that 80 and subtract the next odd number, which is 3. And that is giving us 77. Now this answer as 77, take the 77, subtract the next odd number, which is 5. So if you subtract 5 from 77, we are getting 72. Then we go again, 72 minus the next odd number is 7. And that should give us 65. Then we take the 65, subtract the next odd number, which is 9. So if we subtract 9 from this value, we are getting 56. 56, we subtract the next odd number. The next odd number is what? Is 11. After 9, 11. So subtract 11 from 56. That should give you 45. Now the 45, our next odd number is 13. So subtract 13 from this. That is going to give you 32. That is going to give you 32. Now 32, subtract the next odd number. After 32, after 13, the next odd number is 15. So if you subtract 15 from 32, you have 7, 1. So 17. The next odd number is 17. So this answer, which is 17, subtract 17 from 17, that gives you 0. So whenever you subtract and you hit 0, you stop. So we are going to subtract the odd numbers from the answer or from the result till we get 0. Now after subtracting all the odd numbers from 81 to get 0, count the number of times you subtracted. Count the number of times you subtracted. The number of times you subtracted gives you the answer that is the square root of the perfect number. So let's count and see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We subtracted the odd numbers 9 times to get 0. So it means with this method, it means that the square root of 81 is what? Is 9. And we call these using the method of repeated subtraction with the help of what? The odd numbers. That means if we don't know the odd numbers in order, using this method is going to be very difficult for us. Good. Now let's look at the example 2. The example 2, we can use both methods, but we should know the method which is okay for us, and even we should know the two methods, because a question may be asked, use the repeated subtraction method or just find the square root of the numbers. Once it says find the square root of the numbers, then we can use any method. So the next number here is 64. I have been asked to find the square root of 64. So here, if I want to use the normal way, I'm going to ask myself, what two numbers, if I multiply, I can get or can give me 64? What two numbers? Sorry, what integer will I multiply by itself to get 64? You will notice that 8 times 8, when you are reciting your 8 times table, 8, 8, 64. So since 8 times 8 is 64, then we can rewrite this thing as the square root of 8 squared. Why is it 8 squared? Because it is 8 times 8. Remember, we said that a perfect square is the square. The perfect square is the square of an integer. The square of an integer. So if 8 is an integer, then the square of 8 gives me a perfect square, which is the 64. So now that I have the square root of 8 squared, I will not hesitate to cancel the square root by the square. And that gives me an answer of what? Of 8. Now what if I have been asked to use the repeated subtraction method? To use the repeated subtraction method, we should know our odd numbers, starting from 1 to infinity. Good. So the number that has been given is 64. So 64, subtract the first odd number, which is what? 1. So if I subtract 1 from 64, that is giving me 63. So with this result, which is 63, subtract the next odd number, which is what? 3. That gives you 60. Now with the 60 that we have as our answer, subtract the next odd number, which is 5. Now the next odd number being 5 will give you a result of 55. Now the 55, subtract the next odd number, which is 7. So 55 minus 7, what will be our result? That should give us 48. This 48 that you have, got 48. Subtract the next odd number, which is 9. So if I subtract 9 from 48, that should give me 39. 39, subtract the next odd number, which is 11. And that is going to give me 28. So with the 28, with the result 28, I am going to subtract the next odd number. After 11, we go to 13. So I have 13. Now if I subtract 13 from 28, it's giving me 15. Then with the 15, subtract the next odd number, which is 15. That gives me 0. So anytime I subtract the odd numbers and I hit 0, I'll stop, or I'm to stop. Then I'll count the number of times I did the subtraction. I subtracted 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So it means with the repeated subtraction method, the square root of 64 gives us 8. As simple as that. So with this method, it is simply telling us to use the repeated subtraction method, which means that with the repeated subtraction method, we are going to subtract the odd numbers from the number till we get 0. Once we get 0, we count the number of times we subtracted the odd numbers from the number. That is the odd number from the perfect square to get the what? The answer. Good. So we can use the simplest way, which is the other one, but let's use the repeated subtraction method for 36. We are to find the square root of 36. Now when I'm using the odd numbers, I am just going to ask myself, what is the first odd number? It's 1. Okay. Subtracting will give me 35. So the 35, I'll subtract the next odd number, which is 3. That gives me 32. Now with 32, we are going to subtract the next odd number, which is 5. And that gives you 27. 27, subtract the next odd number, which is what? 7. That gives you 20. 20, subtract the next odd number, which is 9. And the 9 gives you, the 9 will give us 11. So 11, which is the final answer, after subtracting 9 from 20, is 11. Now this 11, we are going to subtract the next odd number. After 9, the next odd number is 11. And 11 minus 11 is 0. So once we hit 0, we've completed with the repeated subtraction. So we just count the number of times we subtracted. We subtracted 1, 2, 3, 4, 5, 6. Which means that the square root of 36 with the repeated subtraction happens to be what? To be 6. And this is a method whereby we can be asked to find the square root of a number. These ones are the normal ones which we were taught in basic 7. We did square root, we look at this type in basic 7 under prime factorization of numbers. Good. But here we are looking at how to use the repeated subtraction method. Using the repeated subtraction method to get the square root of the number. We said that if you are using the repeated subtraction method, we are going to subtract the odd numbers. And odd numbers are numbers that cannot be divided by 2. So since it cannot be divided by 2, then it simply means that number is an odd number. So we are going to subtract all the possible odd numbers from the perfect square in order to get the square root of the perfect square. And the square root of a perfect square, or a square root of a number, it simply means the integer that is the product by itself. which integer is a product by what? Itself. So 4 times 4 is 16, which makes the 4 to be what? The answer as the square root of 16. But we should know that the square root of 16 can easily be calculated to get the what? The 4. But if it comes to the repeated subtraction, we keep on subtracting the odd numbers to get the number, as it has been explained here. So you will see that we have the odd numbers in order. The moment you miss it, you are going to get it wrong. The odd numbers should be arranged in order from the next number to the other number, and that is the repeated subtraction method using odd numbers. Good. So that brings us to an end on the finding of square roots of a perfect square. And I think we can easily find the square root of any given number using a perfect method called the what? The repeated subtraction. It's very simple. By just knowing the order of our odd numbers, we can do the repeated subtraction method. And also subtracting accurately will also help us with that. Now there's something new we want to look at, which is the set of factors of a number. The set of factors of a number. This was taught in Basic 6. And we have an idea of factors of a number. Factors of a number. Now a factor or factors of a number are the numbers when multiplied gives the number. So any number I multiply to get another number, the numbers that I multiply happens to be factors of my result. So example, 3 times 2 is 6. So if 3 times 2 is 6 and I multiply 3 and 2 to get 6, then 3 and the 2 are factors of 6. Which means that a factor of a number divide exactly the number without a remainder. If I should divide this by 3, I'm getting 2. There will be no remainder. If I should divide 6 by 2, I'm getting 3. There is no what? Remainder. So we want to look at how to find the factors of a number for today. And when we meet next time, we'll look at how to represent the factors of a number and how to find the highest common factors of a number on a Venn diagram, which will be a new topic to those of us in Basic 8. Venn diagram, which is very simple to also talk or look at. Now we said that find the factors of 20. Now if I want the factors of 20, I should know what factors are. We said factors are numbers when multiplied gives us the number. So any numbers that when you multiply those two numbers is going to give you 20, then those two numbers are factors of what? Of 20. But to be short, to be simple or short, let us start from 1 and know that 1 is a factor of every number, and the number is a factor of itself. Why do they say 1 is a factor of every number and the number is a factor of itself? It is because when I multiply 1 times the number, it gives me the number. And we said a factor of a number are numbers when multiplied gives us the number. So if I multiply 1 times the number itself and it is giving me the number, then 1 and the number are factors of that number. So we have the next number, we have 2 times 10, which gives us 20. So it means that 2 and 10 are factors of 20. After 2, we go to 3. You see, for us to know the numbers in order, let us assume of counting 1, 2, 3 by multiplying to get the result. So from 1, I go to 3, I go to 2. Now 2 times this will give me this. Now let's go to 3. Is 3 times a number, or is there any number times 3 that will give us 20? No. So it means 3 is not a factor of 20. Now let's go to 4. 4 times what number will give you 20? 4 times 5 gives you 20. So if 4 times 5 is giving us 20, then these two numbers are factors of 20. From 4, where do we go to? From 4 we go to 5, but we already have 5 here. So So that means the mission is what? It's completed. So factors of 20 happens to be pick it in a U shape as 1, 2, 4, 5, 10, and finally 20. So this is the set of factors of 20. And we say it is a factor of 20. That is very good. Now let's continue and look at the last one. Let's find the factors of 18. Looks like we are speeding up because of the time factor. So we have to find the factors of 18. As we said, factors of a number are numbers when multiplied gives you the number. So if you multiply that number, you are getting a factor of it. So what do we say? 1 and the number itself are factors of the number. So 1 times 18 is 18, which means 1 is a factor of 18. 18 is a factor of itself. After 1, if you are counting 1, 2, 3, after 1 we go to 2. So that is going to give us 2. But is there any number times 2 that will give us 18? Yes. If no, then 2 could have not been, well, 2 would not be a factor of what? Of 18. So 2 times what? Is 2 times 9. 2 times 9. Then it means these two numbers, being 18, is a factor, or are factors. After 2, we go to 3. And let's see, 3 times 4 will give us 18. 3, 1, 3. 3, 2, 6. 3, 3, 9. 3, 4, 12. 3, 5, 15. 3, 6. So because 3 times 6 is giving us 18, then 3 and 6 happens to be factors of 18. Then we go to 4. Now recite your 4 times table and ask yourself, is there any number times 4 that can give me 18? If yes, 4 is a factor of 18. If no, 4 is not a factor. So let's go. 4, 1, 4. 4, 2, 8. 4, 3, 12. 4, 4, 16. 4, 5, 20. So between 16 and 20, we have 18, which happens not to be a factor. So it means 4 is not a factor of 18. So if 4 is not a factor, let's go to the next number. After 4, where do we go to? 5. 5, 1, 5. 5, 2, 10. 5, 3, 15. 5, 4, 20. 5, 4, 20. 5, 3, 15. 5, 4, 20. 20 is bigger than 18. So it means 5 is not a factor of 18. After 5, where do we go to? 6. But since 6 has been written here, then the case is closed. So the factors of 18 happens to be, pick it in a U shape as 1, 2, 3, 6, 9, and finally 18. And these becomes the factors of 18. So we just look at the introduction of factors, which God permit. Next week, Wednesday, we will continue with the basic 8 lessons, and on Fridays, we give you the basic 9 lessons. Today, let's quickly do a recall. We look at finding the square root of a number, which is a perfect number. And we said the square root of a number is the integer that when multiplied by itself gives you the perfect square. And we gave an example that the square root of 100 is 10. Why is it 10? It is 10 because we want the number times itself that will give us the number in the square root. So since it is 10, then the square root of 100 is 10. And we've explained this, or the reason why this being 10 to you in this format. That we said that it simply means that because we want the number times itself, it gives us an index of 9 to the power 2, which then 2 will cancel the square root, and that gives you 9. And we also look at how to use the repeated subtraction method, using the odd numbers to find the square root of the number. Thank you for staying tuned. Please, if you have any questions, you can comment it in the, or write it in the comment section, whereby you'll be attended to and we will see you out. Kindly stay tuned. Please subscribe, share for others to also know that easy mathematics is delivering something that is good for us. We'll meet again Friday and bring to you a lesson in Basic 9. See you next time.